Okay, so let's make sure you really get what's going on this problem. So the problem's asking you to estimate the area under the graph of f of x of 1 over x plus 3. So what does that graph look like? That is, you can use your graphing calculator to help you, but that's a rectangular hyperboloid that's been shifted to the left 3 spaces. Yeah, no, I don't expect you to know that. That's okay. So it normally has an asymptote at 0, and now it's going to have an asymptote at -3, a vertical asymptote at -3, horizontal asymptote at 0. Yep, and it's going to look something like this. Okay, and then from this side it's going to look something like this. And it's not terribly important. And in fact, you could actually do this whole thing without ever doing the graph. You just have to understand what the question's asking. So it wants us to estimate the area under the curve going over the interval of -2 to 2. So going from the boundary of -2, so from there up to +2. It wants to know that area, this space in here. Okay, so how are we going to do that? Well, in this section, we have to use approximating rectangles, and it wants us to use right endpoints. Oh, and not only approximating rectangles, it wants us to use 10 approximating rectangles. So what that means, first of all, right endpoints means when we draw our rectangles, we're going to use the y value of our graph that's on the right side of our rectangle and not the left. So if I was breaking this up into a smaller amount, this would only be like 4 approximating rectangles, I do believe. But this would be 4 right approximating rectangles the way I just drew it, because I started on the right hand side and said what's my y value according to my graph, and then go over one up, and then draw a rectangle. Then find my new y value, go over one, draw my rectangle, so on and so forth. Now, and I could find the area of each of these 4 rectangles, and I would have a approximate area for my graph using 4 right approximating rectangles. But it doesn't want 4, it wants 10. So how are we going to get 10? Well, it's the exact same idea, and you don't really even need to draw the graph to do it, but what we need to do is figure out what would the width of each of my rectangles be, because my total width of this area is about 4, right? Going from -2 to +2, I'm going 1, 2, 3, 4. It has a width of 4, which means breaking that up into 10 rectangles, I'm going to do 4 divided by 10, which makes 0.4. So when I draw each of these rectangles, they're going to have a width of 0.4 across. Now, and again, you don't have to draw it. You don't have to even be able to do any of this. It's about the understanding. So the width of each of these rectangles would be 0.4 across. Then I'm going to get my next value and go 0.4. Then my next y value, go 0.4. Then my next y value, go 0.4. And I'm going to keep doing this, and then that would give me a total of 10 rectangles. So what I'm going to do is use my calculator to help me out on this. Whoops, that's not my calculator. There it is. So the first thing I'm going to do is just type in my graph that it wants us to do, which is 1 divided by x plus 3. Okay, so now if I go to my table, it's going to spit out values for me. When I plug in 2, I get out 0.2. So what that means to me here is I know that this value right here is 2 comma 0.2. So the width of my rectangle, so for the area of that rectangle, the width is 0.4 and the height is the y value of 0.2. Now I need my next rectangle. So let's see, I'd move over 0.4, which would put me at 1.6. Now this sounds like, I don't know, not quite some people would have no problem with it. Other people would be saying, okay, I don't necessarily want to go this route and type in each of these values and figure out each of my widths. So instead what you can do is go to your table set, and in here it's saying I'm starting at 2 and I want to count by 0.4s. And if you even wanted to just make the whole list, we go to here, go say auto, there we go. And now when I go to my table, here we are. This is the list of every single rectangle. It's going to be, one's going to be at 0.2, or sorry, 2, 1.6, 1.2, 0.8, 0.4, 0, -0.4, and you'll notice we got the width set correctly because we ended at -2. So now what we're going to need to do is say, okay, my first rectangle again had a width of 0.4 and a height of 0.2. My next rectangle, well, they're all going to have a width of 0.4. And the next one's going to have a height of, and to get as accurate as I can, I'm going to put my arrow over this, and I'm going to say it's 0.21739, whatever, and you can take this out. Plus, and there, what you hopefully realize is every single one of these has a width of 0.4. So I'm not going to continue this. I'm just going to write down my y values. With a height of 0.2 plus a height of 0.21739, so on and so forth, plus 0.2381 plus dot dot dot. Continue that out until you get all 10 values, right? Because that would be 10 rectangles. Make sure you do not include the rectangle of -2, because if you did that, this is -2, which means you're going 0.4 over this way. That's not under the curve. That's the wrong way. With a right approximation, we need to start on the right, and we're going to do 10 rectangles that way. Then the next part of the question asks you to do left approximating rectangles. So you do the exact same thing, but instead of starting at 2, now we're going to start at -2. We're going to start at our left side, go to the right, and go over. I hope that helps. Let me know if you need more.